Hello, my name is Al Kohler. I'm the inventor of the Space Center electronic map that you see behind me. And I'd like to take just a few moments to explain to you some of the details of it for your historical and geography information. First off, let me tell you that it covers 80 square miles of Florida coastline. A coastline, by the way, which is completely undeveloped and probably the only undeveloped coastline in the state of Florida. The map itself covers an area of 80 square miles, and that encompasses 13 miles north and south and 6.5 miles east and west. Now, the body of land that you see directly behind me is called Merritt Island. The body of water from there over is called the Banana River Creek, or Banana River Lagoon, which goes into Banana River Creek. The body of land then beyond that is Cape Canaveral. KSC, or Kennedy Space Center, is located mainly at the north end of Merritt Island. Now, what you're looking at is a map which was developed 30 years ago. And of course, that was pre-shuttle days. And of course, since then, it has been brought up to date to completely include the Space Shuttle and all the very latest projects that have been going on. Now, this map, the way you're going to look at it, doesn't exist anywhere else in the world. And unfortunately, what you see here doesn't exist anymore. It's sort of like walking through a brand new cemetery before the graves were all put in, and then coming back later after all the graves are there and half the tombstones are rotted away. That's the way it looks today. There are really and truly only about 4 or 5 launch stands that are actually in operation today. All the rest are gone. Some of them have been completely disassembled and removed. Some of them still there, just rotting away. Thank you for coming to see the Space Center electronic map. Please enjoy the educational and the entertaining portion of the show. Thank you.
Welcome to the Space Center electronic map. This map describes the history of Cape Canaveral and the Kennedy Space Center. The location of all missile launch complexes are sequenced with the time of construction and first missile launches. This odyssey will take you on a simulated trip through time from the 16th century Cape de Canaveral to today's spaceport and covers over 475 years. The history of the Kennedy Space Center is relatively short, but historians know the Cape more intimately as Cape Canaveral. It is strange that the spaceport of today would be so prominently known as part of the port to the New World, because it was referred to so intensely in nearly all major maps from as far back as the 16th century. In his search off the fabulous island of Bimini, Ponce de Leon, who accompanied Columbus on his second voyage to the New World, discovered the mainland on March 27, 1513, Easter Sunday, and called it Florida, from the Spanish words for Easter Sunday. Exploring the coast to the south, he encountered violent currents when he sighted and named Cape Canaveral. This same cape was considered important enough by the founders of the United States that a lighthouse was established as one of the first 12 lighthouses required for our country. It stands today, serving as it has for over 125 years, the only concrete link between the past and the future. Our nation's technology developed by leaps and bounds during World War II, and when the Allied forces overrunning German-held territory captured the V-2 rockets, including the technical brains involved, the pace toward space exploration quickened. In 1946, a government committee selected the Cape for a missile proving ground. In 1950, the first permanent construction work began at the Cape, and the first concrete launch pads were built. The first missile was launched from the Cape on July 24, 1950. The rocket was called Bumper, and it was a two-stage vehicle consisting of a modified V-2 rocket with a smaller WAC Corporal rocket as a second stage. 3 months later, October 25, 1950, the first Lark missile was launched successfully from a sandbag-type pad. The Lark, a winged pilotless missile, flew a range of almost 10 miles. 8 months later, June 29, 1951, the first flight of the Matador missile was fired from a sandbag-type launch pad. Downrange instrumentation was used for the first time at Grand Bahama Island, opening the range to 200 miles. This Matador didn't fly the full range available. On November 30, 1951, construction was completed on the Central Control Building. This facility provided a central point of control of all launchings for all missiles and rockets launched from the Cape. A missile skid strip was also under construction at this time. The theory for use of the skid strip was to allow a guided missile to be launched from the Cape, fly a round trip downrange, and land on the skid strip upon mission completion. It was 5 years before this actually took place, but the skid strip was and still is used as an airport for the Cape. Nevertheless, the Cape was still an overgrown scrubland, infested with a mixture of palmetto, rattlesnakes, and alligators. The missiles were assembled and checked out at Patrick Air Force Base, and then transported over Route A1A through downtown Cocoa Beach. Then on August 29, 1952, the first Snark missile was launched. The Snark was another air-breathing missile. Remember that during this time, the gaudy red and white missiles were classified as top secret, and the Cape was a hush-hush operation. The following month, on September 10, 1952, the first Beaumark was launched. Beaumark was a long-range surface-to-air pilotless aircraft, designed for high-altitude flight to intercept hostile aircraft. Then came the first U.S.-made ballistic rocket. The Redstone was the largest missile launched from the Cape to this date, August 20, 1953, from the dual launch complexes 5 and 6. The Redstone was a high-accuracy, liquid-propelled surface-to-surface missile. In the meantime, the Cape was continuing to build up, and the missile assembly location had been moved to the new Cape Industrial Area. This new complex consisted of hangars and many other buildings. There were many firsts during this period of Cape history, too many to relate at this time in detail. But on August 19, 1955, the first launch of a Navajo was conducted at Launch Complex 9 and 10. The Navajo program was canceled in 1957, and Launch Complex 9 and 10 has since been disassembled. On September 8, 1955, President Eisenhower directed that the ICBM be given highest national priority, and the Cape took on a new and even more important role in the security and defense of the United States. The ICBM race with the communist world was on. Launch complexes, known as ICBM Row, were contracted for, with planned usage in 1957. Meanwhile, on March 14, 1956, the Jupiter A missile was tested at Launch Complex 26 A and B. The Jupiter was an IRBM. The missile is launched from a vertical position from a small steel platform. Propellants consist of liquid oxygen and a kerosene-based fuel called RP-1. On December 8, 1956, the first test vehicle of the Vanguard program was successfully launched from Complex 18. The following year was the International Geophysical Year, and the Vanguard was to be the satellite launching vehicle. The first stage was only 45 inches in diameter, and its single-chamber engine only produced 27,000 pounds of thrust. The vehicle weighed 25,000 pounds. The second stage was the first hypergolic-fueled rocket, and the third stage consisted of a solid propellant rocket with a breakaway nose cone shielding the satellite. This same launch complex of 17 A and B and 18 A and B consisted of 4 launch pads, and on January 25, 1957, the first Thor had a catastrophic first launch failure. On March 13, 1957, the Bull Goose missile was successfully launched from Complex 21 and 22. The year 1957 was one of mixed emotions for the U.S. because the Russian launch of Sputnik into Earth orbit on October 4, 1957, served notice to all the peoples of the world that they, not the U.S., were ahead in the race for space. This environment increased the U.S. efforts to both success and further failures. 1 month later, April 13, 1957, the first Polaris was successfully launched from Complex 25 and 29. Polaris is a single-stage, solid propellant rocket. The important thing about Polaris is that combined with its nuclear-powered submarine launcher, it is one of the most versatile weapons this country has. However, like all space program, it had its failures. This Polaris launch appeared normal, but that's Stage 2 in flight, and Stage 1 is still on the pad. Destruct was necessary, and Stage 1 destruction had to be performed on the launch pad. The ICBM is of tremendous importance to the defense status of the U.S. And 21 months after President Eisenhower directed top priority for ICBM development, the first Atlas ICBM blasted off from an Atlas complex on June 11, 1957. The Atlas is the U.S.'s first operational ICBM. The distinguishable feature of the Atlas are the 2 lateral pods mounted on opposite sides of the tank structure, which was a lightweight steel, thinner than a dime, pressurized to maintain its rigid shape. You might liken the structure to that of a thin steel balloon. The Atlas program development utilized 4 launch complexes along what is known as ICBM row. Launch complexes 11, 12, 13, and 14 were continuously operational for the Atlas program. On December 6, 1957, the first U.S. attempt to launch an Earth-orbiting satellite ended in disappointment when the Vanguard failed at launch. This was the most publicized scientific failure in the U.S. space effort and another blow to our international ego. "1957 came to a close on a note of failure, but 1958 was to be the turning point, and on January 31, 1958, the first U.S. satellite, Explorer 1, was placed into Earth orbit by a Jupiter C from Launch Complex 26. The satellite weighed 30.8 pounds and discovered the Van Allen radiation belt. Then, on March 17, 1958, the second successful U.S. satellite, Vanguard 1, was blasted into Earth orbit from Launch Complex 18. This satellite revealed the Earth to be pear-shaped. 1958 proved to be a bumper year. Missile after missile was observed being launched from the Cape. 1959 continued the frenzied Cape activity when on February 6, 1959, the first Titan 1 ICBM was launched from Complex 15. The Titan 1 was the U.S.'s second-generation ICBM. The range of the Titan I is 5,500 nautical miles, with a speed in excess of 17,000 miles per hour. To give you some comparison as to what this speed means, if you were to travel from the Cape to Miami, it would take all of 45 seconds. The Titan I and Titan II complexes also consisted of 16, 19, and 20 along ICBM row, and contributed to much of the activity at the Cape during this period of Cape history. We interrupt this presentation to take you to Cape Canaveral for a Titan launch. On April 2, 1959, 7 astronauts were selected by NASA for the Mercury Man in Space project. They were Cooper, Grissom, Carpenter, Schirra, Glenn, Shepard, and Slayton. These first U.S. astronauts are known as the Mercury 7 and are memorialized by the only monument on Cape Canaveral. They have been further eulogized by the U.S. Space Walk of Fame Foundation of Titusville, Florida, by a Mercury Monument and Walk of Fame in Spaceview Park at the city's downtown waterfront. Then, on October 29, 1959, the first mace was rocketed from Complex 21 and 22. This complex was a hardened prototype launch site, capable of withstanding nuclear attack. The year 1960 continued this country's success in space, when the first launch of the newly developed Pershing left Complex 30 on February 25, 1960. The Pershing is a 2-stage solid propellant rocket. Design follows the Army concept of assembly on site and represents the modern status of an artillery piece. 1961 continued this march into space when on February 1, 1961, the first Minuteman was launched from Complex 32. This was more than just another first, as this was the first time all stages of a multi-stage weapon system were tested on the initial attempt. Minuteman was also the first all-solid propulsion ICBM. It is a 3-stage solid propulsion rocket with a range of 6,300 statute miles. Minuteman has extremely long-term storage capability and is launched from underground silo-type facilities. Just as the Sputnik disillusionment was dimming, a Russian cosmonaut was placed into Earth orbit on April 12, 1961, and our national pride took another worldwide backseat. However, like the tortoise and the hare story, on May 5, 1961, the first manned Mercury Redstone, with the spacecraft Freedom 7 carrying Alan B. Shepard, Jr., flew a 260 nautical mile suborbital flight. Remember this man, the first U.S. man in space, Alan B. Shepard, Jr. The race for space was definitely on, and on October 27, 1961, the first Saturn I was successfully launched from Complex 34. Saturn I was a 2-stage clustered engine booster. The first stage contained 8 engines of 165,000 pounds of thrust each, or 1.32 million pounds of thrust. At that time, Launch Complex 34 was the largest known rocket launch site in the world, and the first to be expressly built for the peaceful exploration of space. The first U.S. manned Earth orbital flight took place on February 20, 1962, from the Atlas Pad 14. Lieutenant Colonel John H. Glenn, Jr. orbited the Earth 3 times in the Atlas-launched Mercury capsule Friendship 7. Remember his name, first U.S. astronaut to orbit the Earth, John H. Glenn, Jr. May 8, 1962, saw the first Atlas Centaur launched from Complex 36. The Centaur was the free world's first high-energy space vehicle. The Centaur's first stage was a standard Atlas, similar to those used for the Mercury project. The new element of Centaur was the hydrogen-fueled twin-engine second stage. President John F. Kennedy made 3 visits to Cape Canaveral during his term of office, and he alone is credited with the foresight to establish the man-on-the-moon space goal for the United States. President Kennedy's untimely death in November 1963 resulted in the renaming of NASA's Launch Operations Center to the John F. Kennedy Space Center. Launch Complex 37 was christened on January 29, 1964, when the fifth Saturn was launched. The Block II Saturn I used the same first stage as the original Saturn I, except the booster was rated at a total of 1.5 million pounds of thrust. The test proved the flight capability of Saturn I's liquid hydrogen clustered engine upper stage and demonstrated the vehicle's capability to orbit a 10-ton payload. Gemini was the intermediate step toward achieving a manned lunar landing. Gemini bridged the flight experience between the short-duration Mercury missions and the very long missions of Apollo. The first launch of Gemini took place on April 8, 1964, from Complex 19. The two-man Gemini spacecraft was also bell-shaped, but it was twice as heavy, 20% larger, and contained 50% more cabin space than the Mercury spacecraft. The first manned Gemini flight, Gemini 3, was launched from Complex 19 on March 23, 1965. The astronauts were Grissom and Young. The Gemini program consisted of 12 completely successful flights, of which 10 were manned. Gemini provided the first American demonstration of orbital rendezvous, a skill which had to be developed to land U.S. astronauts on the Moon. The launch vehicle was the modified Titan II rocket. The target vehicle for the Gemini rendezvous and docking missions was a modified Agena-D vehicle with a forward-mounted target docking adapter. The target vehicle was launched on a modified Atlas ICBM from Complex 14. Major objectives achieved during the Gemini program included demonstrating that man can perform effectively during extended periods in space, both inside and outside the spacecraft. The truly integrated transfer launch facilities for the Air Force Titan III standard space launch vehicles was being constructed on the north end of the Cape. The Titan III facility consisted of a Vehicle Integration Building, VIB, a Solid Motor Assembly Building, SMAB, Launchpad 40, Launchpad 41, special connecting parallel railroad tracks and diesel railroad engines and transporters. The Titan III Vehicle Integration Building, VIB, consists of high bay assembly areas, supporting shops, labs, and the Launch Control Center, LCC. The VIB is located on a man-made island in the Banana River. The Titan III Standard Core is assembled and checked out in the VIB, mounted on a transporter, and moved over a parallel set of standard gauge railroad tracks by 2 diesel engines to the SMAB. The SMAB, Solid Motor Assembly Building, is located on another man-made island north of the VIB. At the SMAB, the large solid rocket motors are assembled and checked out separately from the Standard Core. When the Standard Core and payload assembly arrives at the SMAB, the solid motors are attached to the Standard Core while in the vertical position on the transporter. These solid motors are 10 feet in diameter and together develop 2 million pounds of thrust at launch. The assembled Titan IIIC vehicle then continues to the launch pad on the transporter over the rail network. On June 18, 1965, the first Titan IIIC was launched from Launchpad 40. The Titan IIIC is truly a standard space launch vehicle. Titan IIIC vehicles can place 25,100 pounds of payload into Earth orbit and can accelerate 6,400 pounds of payload into a deep space or lunar mission. The Titan IIIC number 8 was launched on December 21, 1965 from Launchpad 41 and completed activation of this sprawling facility of the Air Force. This massive integrated launch facility has been little known by the public and continues to serve the Air Force in a most successful manner. The facility is well suited for space projects of the future. January 27, 1967 was the blackest day in the history of the U.S. space effort. This fateful day records the time the Apollo spacecraft, being readied and ground tested at Launch Complex 34, caught fire and resulted in the death of astronauts Grissom, White, and Chaffee. This catastrophe nearly caused an end to this country's assault on the Moon. Only grim national determination conquered this setback, and the Apollo program survived. The first 3 Apollo spacecraft launches before this black day in January 1967 were made using uprated or Saturn 1B launch vehicles from complexes 34 and 37. However, the delay caused by the fire during the fourth readiness effort resulted in a change in planned schedules. The truly integrated mobile launch facilities of Launch Complex 39 were now ready for the giant Saturn V's. This fantastic development spreads over the greater part of the north half of Merritt Island and is designated as the John F. Kennedy Space Center. The facilities are located in two basic areas. First, the NASA Industrial Area, which houses the administration and engineering personnel and provides test facilities for the Apollo spacecraft and astronaut training. The second part of the Kennedy Space Center is Launch Complex 39, which contains the Vehicle Assembly Building, VAB, the Launch Control Center, LCC, the crawlerway, over which the transporter carries the mobile launcher and space vehicle, and two launch pads, 39A and 39B. The hub of operations at Launch Complex 39 is the VAB. This building is 525 feet high, 716 feet long, and 518 feet wide. The building covers over 8 acres. The Saturn V launch vehicle and spacecraft are assembled and tested in the VAB and mounted on the mobile launcher. The mobile launcher, which consists of a launch platform base and umbilical tower, holding the giant Apollo Saturn V, is transferred 3.5 miles to the launch pad from the VAB over a special crawlerway on the transporter. The transporter is 131 feet long, 114 feet wide, and moves on 4 double-tracked crawlers. Each shoe on the crawler tracks weighs approximately 1 ton. This transporter alone weighs 5.5 million pounds and travels at a speed of 1 mile per hour. The first flight of an Apollo Saturn V was launched on November 9, 1967 from Launchpad 39A. The unmanned Apollo 5 was placed into Earth orbit and initiated use of this massive mobile transfer launch facility. All primary mission objectives were successfully accomplished, and the U.S. space effort was back on schedule. On May 18, 1969, the first launch was made from Pad 39B. Apollo 10, with astronauts Cernan, Young, and Stafford, conducted a low lunar orbit flight and rehearsed the efforts required to place a man on the surface of the moon. Less than 2 months later, the reliable Saturn V boosted Apollo 11 from Pad 39A on July 16, 1969, and the U.S. placed a man on the moon on July 20, 1969. Astronauts Armstrong, Collins, and Aldrin are credited with this climactic feat. This manned lunar landing achieved an 8-year national goal set by President Kennedy in 1961. The spacecraft lunar module, called Eagle, landed on the surface of the moon, and Neil Armstrong, followed by Edwin Aldrin, photographed the moon's terrain, collected rock and soil samples, and transmitted TV pictures to over 25 million viewers in the U.S. April 11, 1970, saw the launch of the near-catastrophic Apollo 13 from Pad 39A. The astronauts were Lovell, Schweikert, and Hayes. The service module's oxygen tank number 2 exploded while en route to the moon, and the astronauts efficiently used the lunar module as a lifeboat to make mid-course corrections to obtain a free return trajectory around the moon and return the command module back to Earth, where the astronauts were safely returned to splashdown. The world spent 4 suspenseful days of prayer for the safe return of these brave men, and the U.S. space effort took another delay. The Apollo program was mankind's giant step toward achieving a space transportation system. The Apollo program consisted of 6 successful moon landings and demonstrated all of the requirements needed to develop future spaceships. Skylab and Soyuz further proved this country's lead in space and revealed the need for a reusable space shuttle. The Space Shuttle program was given congressional approval during the U.S. bicentennial, and work began to modify the Kennedy Space Center. The Space Shuttle orbiter required a special hangar called the OPF, Orbiter Processing Facility, and a new landing strip with special landing guidance systems. The Space Shuttle follows the same method of pre-launch processing as the Apollo Saturn V. The launch vehicle is assembled in the VAB on the mobile launch platform and moved from the VAB to the pad by the transporter over the crawlerway. When the transporter carrying the complete Space Shuttle launch vehicle reaches the pad, the mobile launch platform is transferred to the launch pad, and the transporter is removed from the area. The mobile launch platform is connected to the pad facilities, including the rotating service structure. At the pad, the entire Space Shuttle vehicle goes through a complete checkout. The first flight of the Space Shuttle, STS-1, using the orbiter Columbia, was launched from Launchpad 39A on April 12, 1981. Astronauts for this first flight were Young and Crippen. John Young was America's most experienced astronaut. Young flew on Gemini 4 and 10 and Apollo 10 and 16. The mission profile for the Space Shuttle shows boosted flight for 2 minutes, after which the solid rocket boosters, SRBs, are parachuted to the Atlantic Ocean for recovery. The orbiter, with its external tank, ET, continue until orbital velocity is obtained, and the ET is then jettisoned to burn up in the atmosphere. The orbiter enters Earth orbit for the numerous space experiments and missions. At the completion of the orbital mission, the orbiter returns to Earth as a lifting body, unpowered, and lands on a standard aircraft runway. The first flight landed at Edwards Air Force Base, California. Later flights landed at the Kennedy Space Center. What you just heard is the 2 sonic sound waves generated when the orbiter enters the atmosphere. If you look up and to the right, you'll see the orbiter as it comes in for landing. The important feature of the Space Shuttle is its reusability. The Space Shuttle orbiter and boosters are recovered, refurbished, and reflown many times. The Space Shuttle is the world's first space transportation system and can be likened to early commercial airplanes. The Space Shuttle has truly made Cape Canaveral and the Kennedy Space Center the spaceport of tomorrow. 25 successful flights were made from Launchpad 39A. But on January 28, 1986, the first launch from Pad 39B ended in catastrophe. The Space Shuttle containing the orbiter Challenger exploded after nearly 2 minutes of flight, and all 7 crew members perished. The Space Shuttle program went through a 2-year review and design updating before the flight program was resumed in 1988. The Space Shuttle program settled into a period of international space domination. Astronauts from many foreign countries were trained and allowed flight on the reliable space transportation system. The International Space Station was placed into Earth orbit in the year 2000 by a combined effort of the Russian Proton boosters and Soyuz spacecraft, together with the United States Space Shuttle STS. Both countries have benefited by this cooperative endeavor, which has resulted in friendlier coexistence. February 1, 2003, was a shocking and awakening day for the U.S. space program. STS-107, containing the Columbia orbiter, had been damaged at launch, and during return from orbit disintegrated over the west coast of the United States. All 7 crew members perished. The Space Shuttle program was again delayed. Fortunately, the Russian space program was able to provide added support to the maintenance of the International Space Station, while the Space Shuttle was reviewed and modified for upgrade. The Evolved Expendable Launch Vehicle, EELV program, was initiated by the Air Force to lower launch costs, and the first new EELV, the Atlas V, was launched from the converted Launch Complex 41 on August 21, 2002. Atlas V is manufactured by Lockheed Martin. The EELV, identified as the Delta IV, was first launched from the converted Launch Complex 37 on November 20, 2002. The Delta IV is manufactured by Boeing and uses the only new rocket engine to be designed in the United States in the past 28 years. Review of the U.S. space program revealed a dangerous shortage of trained space-oriented teachers and technicians. The generation of engineers and technicians of the exploratory period of the space age were fast disappearing. Fortunately, one group of space pioneers recognized this situation, and the Brevard Community College of Florida established a program of training for certification of future space tech teachers and technicians. It is identified as the National Aerospace Technical Education Center, called Space Tech. The Air Force, NASA, and other groups have recognized this forward-thinking BCC effort, and financial support as well as property support has been forthcoming. As part of this support, Launch Complex 47 has been dedicated for this Space Tech program. The Cape is fast becoming a large museum, with launch stands slowly rusting away, and nature's never-ending growth reclaiming the landscape. Will the next 20 years obscure this spaceport to leave the lighthouse the only link between the past and the future? Or will the next generation of space techs continue this country's march into space?
What you have seen is the Space Center electronic map, and let me explain to you that what you really see here, like the VAB and all the rest of the stands, are all in proper size to one another. In other words, when you look at the Saturn, as large it is, and you look at the Vanguard, as small as it is, that's the way it really was. Everything is to scale here. Unfortunately, we had to change a little about it. In other words, the land itself was about an 8,000 to 1 scale, and we had to take the launch complexes and multiply them by 10. Otherwise, you probably wouldn't even been able to see them. And then, of course, to make the missiles stand out, we multiplied them by 30. So that when you look at one missile versus the other, it's all comparable. When you look at one complex against the other, they are comparable as far as location and size is concerned. By the way, thank you for coming and to see this map. We do have a black and white book and a full color book, which it tells the complete story, doesn't exist anywhere else in the world, tells the complete story, pictures and sound. And by the way, also, we do have a DVD, which, as if you were visiting here today, you would see the same thing on the DVD. Thank you for coming.